So in part C, we want to solve. We go in alphabetical order m comma n when we solve for the ordered pair. And notice we have m squared minus n squared equals 15, and 2m squared plus 3n squared equals 35. Substitution wouldn't be easy in this case, in case you were wondering, because you'd have to solve it for either m or n, which would involve taking square roots and plus or minuses, right? But what do you notice about both equations? They both have the same kinds of unknowns, right? Which means elimination is going to work well. So in fact, let's eliminate, for the sake of argument, let's eliminate n squared, because it's got a built-in minus, doesn't it? What could you multiply the top equation by to eliminate n squared? 3, right? Because the bottom equation has a 3n squared, a plus 3n squared in it. Now, if we go ahead and distribute that 3 to each term, even the right side, what do you get? 3m squared minus 3n squared by design, right? Equals what? 45. Okay. So what happens when you add everything together? So you get 5m squared equals what? What's 35 plus 45? 80. And then what happens if you divide both sides by 5? How many times does 5 go into 80? 16. Ah, that's not bad, right? And then what could you do to both sides? Take the square root. What do you have to remember in front of the 16? Plus or minus, right? So what is that? M is equal to plus or minus 4. Okay, so m is equal to plus or minus 4, but you have to square it to plug it back into one of those equations. So m squared is 16, right? So I could plug both in at once because the negative would get squared out, and I'll just plug it into the top equation right there. And when you do that, whether it's positive or negative, don't you just get 16 either way? Yeah? So you get 16 minus n squared equals 15, right? What could you do to both sides? And then wouldn't that give you a negative 1 on the right side if you subtract 16 from both sides? But you multiply both sides by a negative, and you get n squared equals 1, which means, well, n squared equals 1, which means n could be, there you go, plus or minus 1. So you get n is equal to plus or minus 1. But it's really all combinations. So aren't there really 4 answers here? Yeah. So you could have, what are all 4? So the way we'd have to separate it is like this. M is plus or minus 4. So that could go with either negative 1. So that's 2 ordered pairs right there, right? Or plus or minus 4 goes with positive 1. Does everybody see that's really 4 ordered pairs altogether? M comma n, right?